Not at the start of class, no. It says no past first or less 10 minutes. Just got all lunch. Maddox still out. Romero, Jaden. Brody is late. 1, 2, 1, 2, 1, 2, 1, 2, 3. Evie is out. All right. Good morning, guys. So today our topic is the last new topic in this unit. So after today, we will be able to spend, I think, fingers crossed, 2 class periods on review, since there's a lot of little stuff in this unit. But again, we got one more new thing to do. So first thing we're going to go over is number 80. That's the notes, and I'm going to do all of those for you. There's actually only one of those that I will ask you to even try before we talk about it, the easiest one on there. One of your handouts is called Difference Quotient Practice 1. I will ask that you do that today. It only has 6 questions on it, but these questions are a little bit longer. And I had you pick up Difference Quotient Practice 2, but based on my 8A classes, we didn't have as much time as I thought to do that one. So I had you pick it up, but we're not. You don't have to worry about the Practice 2 yet. In fact, I'd almost prefer you wait till Tuesday to do that, to force yourself to think about this stuff again. So, difference quotient, I could just tell you how to use it, or what it is, and how to use it, and you would survive for us, I guess. But I want to spend just a couple minutes, and you don't have to copy any of this down, but I'd like you to know what the difference quotient comes from, so that you know what you're trying to do with this. So, the difference quotient starts to show up in the second major thing that calculus tries to solve. The first being 0 over 0. We practice that for days. That's one of the first things calculus uniquely does. The second thing, and where the difference quotient is going to come in, has to do with slope. So, if I ask you to find the slope of a linear line like this, you have some options. You could count rise over run, if you have the graph in front of you. You could do the slope formula if you had the points. This one will be important in just a minute. Or if you have the equation, you should know what part of the equation tells you the slope. So all of that is great, but not everything in the world is made up of straight linear lines like that. A lot of stuff, especially if you become an engineer or you learn enough math to become an engineer, you need to be able to work with things like this. And if I ask you what the slope of this is, it's a lot more complicated because it depends. If you're talking about over here, the slope is something positive. If you're talking about over here, the slope is negative. If you're talking about here, the slope is 0. So we need to, in calculus, have a way to figure out what that slope is. And it changes based on what x is. So the slope would have some kind of x in it. So, okay, last part you don't need to write down. But if I had something like x squared, the best that we could do to figure out its slope is we could take 2 points and connect them with a linear line so that we could do the slope formula. But to keep this as generic as possible, we would maybe make 1 point be x and the y value would be what you get when you plug x into f. And the second point, we say that we are going to scoot over just a little bit to get to the second point, and the amount you scoot over we call h. So that means this point is at x plus h, so whatever this x value was plus h scooting over, and its y value comes from plugging in x plus h into its function. If you take these two generic points and plug them into the same slope formula that you're supposed to know for the ACT, you end up with y2 minus y1 over x2 minus x1, and then the x's cancel out down here, and what you're left with is what we call the difference quotient. So the difference quotient is actually just a slope formula with generic points plugged into it. So this is what we will be practicing today, what this means and how to do the algebra behind it. In calculus, you would do one more step. We don't make you do this step, but at the end of this, if you really want to know the slope at this instant, you want this h value to be as small as possible. So in calculus, we would say in the end, plug in 0 for h by doing the limit as h approaches 0. This is the definition of a derivative, and that is about, well, not about, it's almost all of Cal 1. All of Cal 1 is based on doing derivatives, taking derivatives, and the real world applications. There's a lot of stuff that you can do with that. If you're taking Cal AB next year, derivatives are basically the whole first semester. We do like 2 weeks of limits, everything else is limits. How to take how to do derivatives, what derivatives mean in the real world, and all that kind of stuff. But again, our focus is just on this part today, just the algebra part behind the difference quotient and being able to work with that. So for all of these questions, there's going to be 3 different question types we're going to look at. But the difference quotient is not going to change. So for the 3 question types we will ask you to do, your first step will always be having the difference quotient memorized. Again, you don't have to derive it, even though I just showed you how to derive it, but you do have to have it memorized. And because h is in the denominator, sometimes we may ask you what the restriction is, and so h can't be 0, because we can't divide by 0. So for all 3 of our question types, step 1, memorize difference quotient. And then step 2 is going to be apply difference quotient. So you have to understand what this is asking you to do. So this, f of x plus h, just means you go to f, and everywhere there's an x, you replace it with an x plus h. So that's going to look like that. And for all of these questions, I will try to color coordinate them so that they match up this way. I think that helps you see a little bit. The next part of difference quotient says subtract away the function. And the last part, put it all over h. So the work that you will have to do is the algebra behind simplifying this. I would say that this question type is the one you'll probably feel the most comfortable with, just because you've done this type of algebra the most. You could FOIL this. Remember, x plus h squared is not x squared plus h squared. If you need to, write it out to the side and actually FOIL it. It would be x squared plus 2xh plus h squared. Some point you're going to distribute this 5. At some point you're going to distribute this negative. And it's still all over h. One other thing I think I could do reasonably is distribute this -2. Try to leave everything else alone. Okay, so if you had just walked into class just now, it would probably look pretty intimidating. But again, the setup, we're going to practice every single question. And what I've done since then is I foiled this, distributed a 5, distributed a negative, and then distributed -2. All things you guys have done for a long time. Now the question is about to be finished here, because even though this is really messy, most of this in the numerator is going to add up to 0. We've got 2x squared minus 2x squared. We've got a 5x minus 5x. And so a lot of stuff will just go away. And so for all three of these question types, they're going to start off the same way, the same first two steps, and they're all going to finish the same way. So I'm going to highlight that because it helps you see what you should be aiming for. But notice everything in the numerator has an h left over. So if you factor out the h as a GCF, your very last step should be doing the times h divided by h cancels out. So we would be trying to get to -4x minus 2h plus 5. That is the difference quotient applied to that function. Now again, I'm not going to keep talking about the calculus part that you're not responsible for in this class, but if you then did the limit as h approached 0, which basically just means you plug in 0 for h, you would be left with -4x plus 5, which is called the derivative. And the derivative is like a formula to know the slope of that function. If you want to know the slope of that function when x is 20, you could plug 20 into -4x plus 5. If you want to know the slope when x is 0, you could plug 0 into x to -4x plus 5. And you can determine the slope for any value of x. And again, the real work here is stuff that you guys have done before. It's just kind of pulling all these pieces together. FOIL, distribute, 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 combine like terms, GCF, and last step for all of these will be dividing out the h's. Okay, the second question type, still going to start off the same way, still going to end the same way, but based on this being not a polynomial, it's going to have a different algebra in the middle. So, step 1 is you still need to memorize the difference quotient. My suggestion is to force yourself to write it down on every question for the repetition. And then step 2 is applying the difference quotient. So here in red, it says go to the function, and everywhere there is an x, replace it with an x plus h. The purple part tells me to subtract the function, and the black part says put it all over h. So you might end up thinking this question type is more difficult, but the first two steps are not more difficult. Memorizing the difference quotient and applying the difference quotient. Doesn't matter how messy it looks here. I haven't really done any math step behind this. Now, since this is not a polynomial, we can't just do foiling and distributing a few times and be done like we did on the question 2. I guess you could distribute this 3 if you want to, but I would just wait till later if you need to. So the trick to simplify something like this is a mathematical trick that we have talked about recently. You need to multiply the top and the bottom by the conjugate of the numerator. Remember, conjugate just means change the middle sign only, the sign between the terms. So it was minus, now it's plus. You've got to multiply the top and the bottom so that it's like you're multiplying by 1 and not changing the size. Now, same thing as the last question. If you just kind of look at it halfway through, it looks pretty intimidating, but it does kind of fall into place pretty quickly here. If I multiply these two fractions together, denominator times the denominator, I'm just going to leave it h times this stuff. But the numerators, the numerator times the numerator, is going to simplify a lot. I know that because I'm multiplying it by its conjugate. That's the whole reason conjugates are important in math, is that it makes it simplify out nicely. So the first part of FOIL, if I multiply the square root of something by the square root of itself, you just get that something. So that would be 3x plus h minus 1. I'm going to go ahead and distribute the 3 there now. Feel free to do the outer part of FOIL and the inner part of FOIL, but since those are conjugates, they're just going to cancel out and add to 0 anyway. So since that always happens in mathematics, you don't have to show that. And then the last part of FOIL, the square root of 3x minus 1 times the square root of 3x minus 1 would be 3x minus 1. But 1 is positive, 1 is negative. That means the 3x minus 1 is negative. Be careful not to just make the 3x negative. It's the whole 3x minus 1 that's negative. Okay, I'm going to go ahead and distribute this negative though and just change this to minus 3x plus 1. Okay, now this is where it's going to finish like question 2. A lot of stuff in the numerator is going to cancel out. 3x minus 3x plus 1 minus 1. And in the end, the very last step should be canceling out h's. Times h divided by h. The answer we're aiming for here is 3 over all of this stuff. There's just nothing else we can do with that. Again, if you wanted to plug in 0 for h, you would then have what's called the derivative, which again, if you're moving on to calculus next year or some point in your life, you'll realize how important derivatives are. So again, just a quick 10-second recap. Same first step, memorize difference quotient. Same second step, apply difference quotient. Different third step. For this question type, you have to know to try to multiply by conjugates. The denominators didn't really do much, but the numerators canceled out, or multiplied nicely, canceled out nicely, and your very, very last step should be canceling out h's. That should be true for all 3 question types. Okay, the last type, again, there's 3 types we're having you look at in this, although you could apply this to lots of different function types. But the last type we're looking at is a rational function. So step 1 is still memorizing the difference quotient. Step 2 is still applying the difference quotient. You're just basically doing what it says. Plug in x plus h into the function, then subtract the function, and then put it all over h. The end of the question is going to be the same, but now here in the middle, this is a different question type, so the algebra is going to be a little bit different. There's nothing to FOIL or distribute yet, like question 2. There's nothing to do conjugates of, like question 3. But luckily, we have reviewed this algebra thing recently, because that makes it a little bit easier. This is a complex fraction. I've got smaller fractions within a bigger fraction. So we're still going to deal with this complex fraction the same way we did last week. In that, I would love to multiply this by x plus 8 to make those cancel. But if you multiply one term by x plus 8, you better multiply everything by x plus 8. I would love to multiply this one by x plus h plus 8 to make those cancel, but same thing. If you multiply one term by that, they all get multiplied by that. Also, just like we did complex fractions last week, I warned you this gets really messy, so if you're not careful, you'll miss the question just by sloppy handwriting here. But in the end, I'm left with this times this, so I'll go ahead and FOIL those. Over here, I'm left with negative x times this stuff, so I will distribute the negative x. And my denominator has the h that's been there the whole time, the x plus h that I had to multiply everything by, and the x plus 8, h plus 8 that I had to multiply everything by. So at the end of that, basically I just multiplied everything by the smaller denominators so that it goes from being a complex fraction to not being a complex fraction. I realize, again, that's not, simplifying complex fractions is not the easiest algebra skill, but it does show up as you guys are moving up in mathematics. So it's good to know how to deal with that. Now it should finish just like the first two types did. Most of this stuff should go to 0. X squared minus x squared, 8x minus 8x, plus xh minus xh. Wait, hold on. I might have a mistake there. Yes. Yeah, thank you. Right here, this last part of FOIL should have been 8h. Is that what you were going to say? Yeah. So, again, after you guys do a few of these, you'll be able to catch that in the same way. Because, again, it's very formulaic at the end how it's supposed to cancel out. So that's how I knew something was off. Again, x squareds add to 0, 8x's add to 0, xh's add to 0, and your last step for all three question types, that kind of red flag that helps you know if you did something wrong or not, like what just happened to me, is you should be canceling out an h with an h. Times h divided by h cancels out, and our answer would end up as 8 over x plus 8 over x plus h plus 8. That's where we want you to go. So difference quotient still the same, applying the difference quotient still the same. We had to simplify our complex fraction, but then it's simplified in a pretty common way. Most stuff cancels out or adds to 0. Most of these like terms go away, and the last step should be canceling out h's. Just like the last step here was canceling out h's, just like the last step here was canceling out h's. So that's your kind of clue if you have a mistake or not. Okay, I'm still going to do a few more examples for you guys, but I have the easiest possible function I can give you that I want you to try to apply the difference quotient to. And when you get your answer, I'll give you a couple minutes to try it before we discuss it. When you get your answer, I hope that when you see your answer, that answer makes sense to you. So that's the only hint I'm giving right now. But go ahead and try to apply the difference quotient and simplify it as much as you can. Okay, so again, I think you probably have a good hint. I hope you have a good hint on whether your answer is correct or not here. Your answer should just be a number. But if you tried the different, again, this is easier than we would ask you to do, but it's also, I just showed this to you 10 minutes ago. So here's the difference quotient. Here's what it looks like if you plugged in x plus h. Here's what it looks like if you subtract the function and put it all over h. And then the algebra behind this one just simplifies quite a bit nicer. You could distribute the 2. You could distribute the negative. Most things are going to combine and add to 0. And your last step should be canceling out h's. So the answer you should have been aiming for was a 2. Why do you think I'm saying that this hopefully seems correct to you? Why should you have known the answer to that was 2?
Because in mx plus b, that's the m.
Right. Remember, the part that you don't have to know, I just wish that you did, the difference quotient is just a fancy way to find the slope for any function, whether it has curvature or not. Difference quotient is slope. This was in mx plus b, so we really knew what the slope was from the beginning. The slope was 2, so it makes sense that the difference quotient tells us it's 2. There's no x's here because in a linear equation the slope's always the same thing. So that's where I was hoping that you would catch that. Okay, there's a couple more on this page, so I'm going to continue to go over these with you and for you because I do think you need to see more examples. And then when we move on to the next worksheet, I will have you do one of each type as guided practice before I leave you on your own. So, again, for now you can still just follow along and copy me. Difference quotient, the x plus f of x plus h part, the minus the function part, and the over h part. If this had started off as a polynomial, I would just need foiling and distributing. If it had started off as a radical, I would need to be multiplying by conjugates. But since I started off with a rational function, I was left with a complex fraction. So we need to multiply everything by this small denominator, 2x plus 5. We need to multiply everything by this small denominator, 2x plus h plus 5. And of course, with complex fraction, if you're going to multiply one thing by something, everything gets multiplied by that. It's all or none. Gets really messy here, and I did miss this part. I might have said it, but I didn't write it down. I didn't multiply that by 2x plus 5. So be careful with what was not canceled out. Looks like we have a 2x plus 5 times 1. Then over here we have a negative 1. You do have to treat this like a this minus like a negative. You could distribute this minus 1. I already distributed the 2. And my denominator's messy, but it doesn't really matter. We don't need to do too much with the denominator. Multiplying everything by the smaller denominators gets it out of complex fraction form. Once it's out of complex fraction form, we should be almost done. All of this numerator should basically go to 0, 2x minus 2x plus 5 minus 5, and for consistency, the last step should always be the same. This is negative 2 times h, this is h times some other stuff. Timesing by h and dividing by h can cancel. This is what we would want to see as your final answer. Now, if you don't distribute this 2 here, if you left this 2 times x plus h, that's fine too. That's equivalent to it. It's not any better or any worse. Okay, so I know the first few times you see them, you should have lots of questions, but now you've seen 2 of these, so you've probably narrowed down some of the questions you may have anyway. So is there anything that you guys would like to clarify on this question before we do another? Okay, so I got 2 more I'm going to do for you, and then 3 more I'm going to have you try before I go over them with you. Okay, difference quotient. Applying the difference quotient. Think about what type of algebra you need to simplify that, whether it's fixing a complex fraction, whether it's multiplying by conjugates. For this one, I think this is probably the type, I think if you start off with a polynomial like this is probably the type you're going to feel most comfortable with. We could FOIL this. Now, there's a good chance in a few minutes someone's going to ask me, where did this 2xh came from? It's because I'm foiling this. X plus h squared is not x squared plus h squared. It's x plus h times x plus h. Write it out to the side and FOIL it if you need to. Distribute a -2, distribute a negative. There's a lot of stuff, but again, the steps shouldn't be too bad. Combine like terms. Most everything should go away. Everything that's left over should have an h in it. So if it helps you to see it, factor out the h, and your last step should be canceling out h. Again, I know you guys know how to FOIL and distribute and combine like terms and factor out GCF, but it's more challenging when you have to do 4 or 5 of those steps on your own without being told what steps to do. So, very good algebra practice. Okay, same thing. If you guys have any immediate questions about this one, it makes sense to go ahead and ask. So, anything you want clarified on number 7?
Can you explain how you went from the second step to the third step?
Is this the second step? Huh?
Specifically on the numerator.
Is this what you're calling the second step?
Oh, yes, sir.
Okay, so are you okay with why all these terms are canceled out?
Yes.
Okay, so I just saw that this term, and this term, everything that was left behind had an h in it, so I factored the h out front. So do you see if I distributed it, I would get 2xh, h squared, and minus 2h. And the only reason I did that is to help you see that these two should cancel.
Gotcha.
Really, this can cancel out this h, and this h. And you can do that if you see that. It's just, it's a little shakier algebra-wise. Some of you might only do 1, or you might do 2 of them and not all of them. So if you factor it out, it's a little easier to see. Okay, and then one more polynomial. Again, we're leaning heavily on the repetition to make it easier. Same difference quotient. Same way to apply it. Gonna finish basically the same way, but the algebra in the middle just depends on what type of question you started off with. Okay, so I know that I need to, now right here, I guess one mistake that could happen is you might be tempted to multiply the 2 and then square it, but you got to do order of operations. You got to do exponents before multiplication. So the safe play would be to not distribute the 2 and just FOIL first step. We can distribute the 2 in the next step. Distribute a negative, distribute a negative. Since I didn't distribute this 2, I'm going to go ahead and do it now. And I'm going to cheat a little bit. I'm just going to put it right above here. You know the last step is supposed to be canceling out h's. So when I cancel stuff out in a second, if there's some stuff left over that does not have an h in it, that's a red flag that you misfoiled or misdistributed or something. But I've got a 2x squared to cancel out with a minus 2x squared, a plus x and a minus x, a plus 3 and a minus 3. Every one of the rest terms has an h in it. That's why we can take an h out of all of those and divide it with the denominator. If it's easier for you to see, factor out the h first, and then it's easier for you to see why the h's cancel. So again, you could apply the difference quotient to basically any function, but we are asking you to focus on 3. We will not ask you to do anything outside of these 3. In fact, on the test, we may not even have you do all 3. I don't know. But this is what happens with the polynomial: foiling, distributing, combining like terms. This is what happens if you start off with a rational. You have to simplify the complex fraction before you can combine like terms. And this is what it would look like if you start off with a radical function. You need to multiply by the conjugates before you can combine like terms and cancel out your h. Okay, so you're not totally on your own at this point. Oops. I still would like to do 3 of these as guided practice. So go ahead and try, make sure you're on the correct worksheet here. We're just doing practice 1 today. Again, I had you go ahead and pick up practice 2 for next class, but you don't have to do any parts of practice 2 today. I just need you to practice practice 1 with your best effort, please. So, try question 1, see how far you get before you get stuck, or see what you come up with as an answer, and then I will go over it and help you out if you did get stuck. In fact, I'll go one step further and I'll go one step further and even share with you what the answer is supposed to be. That way, if you're getting the same answer as me, you don't have to wait on us and you don't have to listen to me go over it. If you've got the answer down, then you probably got that question typed down. So the answer's on the board. I would say if you got this one correct and you think you're going to be waiting a few minutes, you're welcome to do the top question on the back page because it's the same question type. everybody another 3 minutes. If you're still not finished in 3 minutes, you should at least know where you got stuck. Okay, so you should have either gotten that as an answer on number 1, or you need to follow with me to see what went wrong. Okay, so if you started off plugging in x plus h, it's going to look like that. And then if you subtract the function and put it over h, I would expect to see that step in all of your work. Showing your work is mandatory on these, as it says in the directions. Then, if you FOILed this out correctly, I'm going to highlight this part because it's the part that I think is going to have the most mistakes. And we could go ahead and distribute the -4. And might as well just distribute this negative while we're at it. Okay, and since I didn't distribute the 3 last time, now I'll distribute the 3. Okay, and I guess you could actually start combining like terms sooner if it drives you crazy that there's too many things up there, but you're going to have to redo it at the end anyway. There's going to be some new stuff. But those add to 0, these add to 0, those add to 0. Everything left has an h, so factor that out. And then to finish off, times h divided by h cancels. So that is where I got the 6x plus 3h minus 4 as a final answer. So if you did not get that, and that was not enough, I need you to try to tell me what parts of that you'd like me to verbalize again. Any parts of 1 that you want explained again. Okay, Then please do the same thing with number 2. And just to help you make good use of your time here, when you're done with 2, I shared my answer again. So if you got that right, you shouldn't need to hear me explain it again, and you can tune me out when I go over question 2. While you wait, you could do the second question on the back since it's the same type. If you got this one right, you should be able to get that one right. All right, does anybody need more time for number 2? It's fine if you do, I just don't know. All right, again, if you got number 2 right, you don't have to follow along with me. It's perfectly fine. You're not going to accidentally get that as an answer. So, but for those of you that need to see it, here is the x plus h plugged in part, the minus the function part, and I know it's a pain to keep it over h because you don't need that till the end, but you need to include that each time. You can't say this is equal to the next step if you don't do that. So for this question type, foiling and factoring doesn't do much for you. It's not a complex fraction, so you can't do that. This is the type where you have to know to multiply by the conjugate of the numerator. Numerator because it's the one with the square root stuff. So this minus sign became those plus signs to be conjugates. So the denominator is going to stay messy. It's going to stay h times all of this. I want to leave that h out front because in the end, I know that last step is going to be to cancel that out. But multiplying your numerators should look a lot nicer. The square root of something times the square root of itself just gives you that thing. I'll go ahead and distribute the 3 while I'm at it. The outer and inner part of FOIL are going to add to 0 anyway, so I'm going to skip those. You can do that, it's just going to be a little messier first step. And then the last part of FOIL, square root of 3x minus 5 times square root of 3x minus 5 would be 3x minus 5. I would say the most common mistake is going to be right here. Positive times a negative is negative. I know you all know that, but sometimes you guys do it like this. And if you do it like this, you're saying that 3x is negative and not negative 5. All of 3x minus 5 is negative. Or you could just distribute it right away and say negative 3x plus 5. Then combine your like terms. Plus 5 minus 5, 3x minus 5, 3x minus 3x. And then in the end, you might want to write it one more step before you go to your answer. But the only thing left in the numerator is 3 times h. The only thing in the denominator is h times this mess of stuff. So h is a factor and h can cancel out. Which is where I came up with that as an answer. So once again, knowing to multiply by a conjugate, you kind of just have to memorize. At some point in your math career, it's a little more intuitive just because you can kind of see, you're more likely to see when it might help.
Will it always be like that, where you're going from, I guess essentially multiplying the same thing in that second step?
Here?
Yes, where you said they would cancel out anyways, so you don't need to worry about it.
They're going to cancel out anyway.
It was the where you're distributing right there.
Right here?
Yes, sir.
Well, I probably shouldn't have said that it wouldn't matter, but I know that all of it's going to go away. So the thing is, if you make this 3x negative and you forget to distribute it, and you think this is a minus 5, your minus 5 and minus 5 is minus 10, and then all of a sudden you can't cancel out this h. So hopefully that's enough of a indicator that something's wrong to you, and then you can go back and try to see that those really go away. So okay, so that's the second type that we will be asking you to do, and then the third and last type. So last one we'll do guided practice on. So if you have not tried question 3 yet, please do. took me a second. One's a little harder to compute over, but there's what your final answer should be on 3. So as you finish that, if you've got that, go ahead and move on to the back. And if you don't end up with that as an answer in a few minutes, you need to follow along with me when I go over it. Would anybody like more time on 3 before I go over it? Okay, then if you did not come up with that as an answer, this is what your first step should look like. Let's see, x plus h. F of x plus h minus f of x all over h. Then to make this look nicer with algebra, this is a complex fraction, so that's our first problem, is getting it out of complex fraction. So multiply everything by 3x minus 2 to make those go away, and multiply everything by 3x plus 3h minus 2 to make those go away. And I did multiply this one by 3x minus 2. Make sure you multiply everything by whatever you multiply one of them by. So after that, you should be left with 5 times this, or 15x minus 10. The next part, I would say if you struggled, you might have lost this minus sign. Sometimes it's a good idea in math, if it's minus a fraction, you might want to change it to plus a negative. It's the same thing, but it gets your negative right here where it's harder to miss. So negative 5 times all of this stuff. You can see I distributed that 3 earlier, so that makes it work out a little bit nicer. That gets you down to here, and honestly, if you can get to this part successfully, then you're probably just fine, because you've had more practice finishing these. 10 minus 10 goes to 0, 15x minus 15x goes to 0, times h divided by h cancels out. In the end, you should have been left with only a negative 15 in the numerator, and a 3x minus 2 in the denominator, and also a 3x plus h minus 2 in the denominator. Now you can see over here I distributed the 3, and over here I didn't. They're basically the same. One's not better than the other. So if one was more simplified, then we should stick with that, but it doesn't matter. So
can you explain the negative 5 times the 3x plus 3h minus 2? You distributed that?
yeah, so negative 5 times 3x gave me this negative 15x. The negative 5 times 3h gave me negative 15h. And then the negative 5 times negative 2 gave me a positive 10.
Okay, gotcha. So you simplified that before. You distributed 3 before.
Oh, yeah. So the only thing is, if you don't, it would look like 3x plus h minus 2 like this. It's just a little trickier to distribute this because you're not distributing it to a 3. It's almost like you're doing negative 15 times x, negative 15 times h, but then only doing negative 5 times negative 2, because this negative 2 is not being multiplied by 3. So since that's a little weirder that way, I just distributed the 3 first. But whatever you're more comfortable with. All right, the good news is, if you're doing AP Calculus with us next year, we don't really have to do this much in calculus because our AP exam does not make us do it this way. If you don't take calculus until college, there's a good chance you will have to do this quite a bit. When I took Cal 1 in college, my professor had us do derivatives by the definition on every single test. There was always one question on every single test where we had to do that, and it was basically this work. Again, the only thing I did additionally was plug in 0 for h at the end, but it is an important concept in calculus, but since it doesn't get tested on the AP exam, we just don't spend much time on it in AP Calculus. But for us, it's good arithmetic practice, it's good algebra practice, complex fractions, conjugates, foiling, order of operations, combining like terms, GCF. Just a new way to appreciate all those skills and hopefully give you some insight on how they could help you something more complex in your math future. Okay, so with our new bell schedule here, you guys have 35 minutes today to finish up class. There's one thing I'm asking you to turn in that's on the board, and I would like you to finish the back page of practice 1, so that would be one more of each type. I guess if you really want to start working on worksheet 2, you can. I will ask you to do it next week anyway, but honestly, I would kind of prefer you to wait just because, I don't know, it's good for you guys to have to make your brain think about it another time. So I would say worksheet 2 for next week if I was you, but finish up worksheet 1. Make sure you have 78 turned in from last class, and you've got 35 minutes of class time to do that to avoid having homework here. If you'd like me to look at your work and help you out, then of course I'd be happy to. Just let me know.